Hi there, I'm Don. I like to experiment with stuff. So over the last couple of months, I've been building around agents and basically trying to build a framework that makes it easier to build agents. And in the last few months, like 2 months ago, I started working on an agent orchestration tool called Proxima. And Proxima basically makes it easier for you to create agents and have them run workflows that involve connecting to a lot of different apps, from like developer apps like GitHub, Linear, Posthog, Railway, yeah, to marketing and social media apps like X, LinkedIn, Instagram, and TikTok. And the thing that comes with giving agents the ability to connect to all these different tools is around the fact that as you increase the number of tools that your agents need in order to achieve a certain task, the amount of effective context window that's left for the agents to think reduces significantly. In order to solve this problem, there are a couple of different approaches that have been taken. So the first ones is to introduce delegation, whereby you basically have your main agent instance delegate whatever task that needs to be completed to a sub agent, and that sub agent basically handles the execution of that task. However, with delegation, you're still running an agent loop, and the actual problem is not tied to the ability to delegate, but tied to the fact that tools and tool results that enter into the agent loop compound over time, and the main like context killers. So, in order to solve this problem a lot better, the approach that needs to be taken needs to focus on how to reduce the amount of the context window that gets eaten up by tools and tool results themselves. And so one of the other approaches that has been taken is called code execution. And the way code execution works is it's based off the fact that models inherently have the ability to understand code and write code, and also they understand Unix systems and file exploration and Bash. And so with code execution, what you basically do is define the tools as executable files within a sandbox, and then basically have the agent progressively discover the tools within that sandbox and have it compose them to achieve whatever task it's trying to achieve without ever leaking the intermediate results to the model's context window. This approach has been shown to uh, reduce the amount of effective context window that gets eaten up by tools and tool results. The only issue with code execution is it introduces another dependency, which is the sandbox itself, where the agent is going to be running the code and where the agent is going to be writing and running the code and handling and managing the intermediate results before final results make their way into the context window. And that can be prohibitive, especially in the situation where you're unable or you're in an environment that's constrained and can't handle spinning up additional sandboxes in order to achieve code execution. One approach to this is to build an emulator that provides the model with the same utilities that it would find when writing code within a code execution sandbox that's Linux based. But then that introduces its own sort of problems around needing to build an emulator with parity to a Linux box that the agent expects to be operating on. There's also the other requirement of having to build a harness which can effectively control the code execution capabilities. So if you read through the blog post by Anthropic, it's basically describing a list of things that need to be available in order to provide an agent with the capabilities which come from code execution. So you don't necessarily need a sandbox. There are three main capabilities. It needs to be something the model already inherently knows. Two, it needs to be composable. That means the agent needs to be able to compose results from different tool calls within whatever environment you end up providing. And three, it needs to be able to hold intermittent results. That's once the model is done running a specific once the model is done running something, the results can be held intermediately, and the model can compose it with results from other following tool calls. So if you read through that list, it doesn't explicitly say it needs a Unix sandbox with bash capabilities and terminal capabilities in order to provide the benefits of code execution environments. So that means there must be alternatives. And the alternative I found that fits best for this purpose is basically a database and SQL, because models, regardless of their size, already understand SQL and databases, as these have been kind of some of the core languages that were trained into the model. So you'd have like a 3 billion parameter model and a trillion parameter model all have similar SQL composition capabilities. So that means basically a 3 billion parameter model, which may have issues with specific tool schemas, will actually understand and write clean and runnable SQL the same way a trillion, multi-trillion parameter model would. And regarding the second point, which is composition, composition comes built into databases and languages in general. With SQL specifically, that means we're able to pass results between different queries. The results of a select can be the input of an insert and so on. So composition comes in by default when building on top of a database and using SQL. So regardless of the amount of tools that need to be composed in order to achieve a specific task, the model can simply write a single SQL script that can compose all the tool calls that need to be run. And that single script can essentially do whatever intent the model has in mind in order to solve the user's request. And regarding the third point about the model being able to compose, regarding the model operating in an environment which can hold intermediate results, when the model writes an SQL query that basically composes different tools, the emulator itself will handle passing down of results between the different tools that are involved in running that specific query. So that kind of comes in by default, and the model understands that by just understanding SQL. So a simple example of how this could work would be a simple table, like let's say a table called time. And basically the model wants to know what the current time is right now. So all it needs to do is just write a select over the table time and get the current time. So although this is a simple example, it does compose over to even more complex queries that may be compositions of a bunch of different like CTEs, selecting results from like different and putting them all together. So the model essentially never actually sees the plumbing. It just sees and writes SQL, and the SQL runs as it expects within the emulated database environment. A couple of things also come in when you take the approach of using a database. First, discovery is on by default because uh, SQL already SQL and Postgres databases already have a way of doing discovery of what tables are available, what the schema of things are. So that's just a given, and that models already know and expect to be available. Because there is no Unix box to spin up, this is able to run essentially where your process is running. So that could be on the edge or basically wherever. And you don't need to manage or handle or pay for spinning up sandboxes in order to have your agents get the benefits of code execution. Glove-scratchpad is a dependency-free Postgres subset engine, and it basically enables you to define resources and also define how reads and writes map onto the actual tools that are going to get called by the model. And it only mounts a single executed SQL tool onto the agent, and the agent basically uses that executes SQL tool to explore all the tools that you provide. This is way cheaper to spin up as it's in process, and it runs on places where a sandbox wouldn't. So in order to test Glove Scratchpad, I created a benchmark, and this benchmark was mainly testing how effective the different approaches were as the tool surface that the models or agents were working with scaled. And in all scenarios, I found that making use of Glove Scratchpad, the Glove Scratchpad with SQL variant was more effective, used a lot less context than the baseline approach where all tools were basically loaded into the agent. I think the results are a lot similar to code execution across MCPs that were reported in Anthropic's blog post. The one thing that SQL couldn't do correctly was branching. And by branching, I mean basically executing based on specific predicates. So basically, like if else statements. And so I also explored an implementation of the close scratchpad using closure. So kind of a Lisp variant to the SQL variant. And this was a lot useful whenever the model needed to compose tools in a way that it needed to basically include branching into the composition. And just in the spirit of testing, I also decided to provide the agent with both tools, so both the ability to access the Lisp emulator and also the ability to just write SQL. And I think for most pieces, it was pretty clear that the models preferred using SQL over Lisp most tasks. But when they needed to do any kind of branching, they chose using the Lisp. So I think the lesson to take here is perhaps provide the agent with both approaches and have it choose based on the task it's working on, which one to execute for that task. And finally, in both approaches, both using Lisp and also using SQL, in both cases, they all performed better than the baseline where you had tools loaded into the model's context window. I think the takeaway here is not that SQL is like a magical way to handle code execution, but just that we need to build on top of the fact that models already have inherent knowledge in doing certain things. And so if we can build emulators or harnesses around that fact, then we can simplify some of the ways in which we're approaching solving problems around context windows and other stuff like it. My goal with this was to reduce the costs of running Proxima, and I'm gonna be monitoring that over the next couple of weeks as it's deployed to most of the user base. And so, yeah, I guess I'm just testing this out. The benchmarks gave me confidence in deploying it to my live production systems. So, yeah, I'm just gonna test it out, see what happens. Yeah, hopefully, the results from the benchmarks hold on production, and there's a significant reduction in how much I need to pay for tokens overall. So if you got to this point, thanks for checking this out. Yeah, I'm curious to know your thoughts. I'll also include links to all the research that I did, as well as to the code base, so you can inspect for yourself or have your agent inspect it on your behalf. I'm also curious to know what you guys are researching or experimenting with around agents. So thanks for watching. See you later.